So the homework that was assigned last week, that is due today. So go ahead and turn that in. If you haven't done so already. This was the homework regarding the inverse trigonometric functions. And so from there, we only have one homework left, and then the final exam. So just to reemphasize, the final exam is a week from today. The final exam is a week from today. It is in class. So if you do not show up to class, you do not get any grade for the final exam. You get a 0. So please come to class next week, unless you have other arrangements planned, such as accommodations or such. So again, the midterm, it's in class. It should take you about, at most 90 minutes. I'll give you up to 90 minutes to take the test. We'll talk more about it Thursday. Thursday will be a test review session. So besides for that, I'll just go ahead and start talking about the final section for this class, which is on trigonometric equations. So I have a few problems from here, a few homework problems as well. We might be able to talk about 1 or 2 of them if we have enough time, but this will be the last section for this test. And then any information regarding the final will be discussed this coming Thursday. So this is a section on trigonometric equations. As you can see, this is section 6.2 in the book. So do not do the wrong section. And this is a section, well, it's trigonometric equations. So it's trig functions in equations. And we solve these equations where half of the solving is using algebra techniques, as you will see momentarily. And then the other half is using trigonometric techniques. So what I mean by all of that can best be summarized by just doing some of these problems and explain what I'm referencing. So for example 1, they want us to solve this equation over the interval 0 to 2 pi. And so to solve this equation, well, ultimately solving an equation, that means getting x by itself. Well, what we did, so as I mentioned, half of this is algebra and the other half is trig. The first half is going to be algebra. And where the algebra comes into play is getting the trigonometric function by itself. Now, something you could do, since we're trying to get the trig function by itself, if you remember U substitution, it might be a good idea to make a U substitution of whatever the trig function is. I see sine of x, I make U equal to sine of x. So if you did not like U substitution from college algebra, we're not doing anything intense with U substitution. It's more so a placeholder. And you'll see why as we move forward. But in this problem, the U substitution, so now it's U plus 2 is equal to 3 because I swapped out sine of x with U. Again, it might seem trivial here, but it makes a little bit more sense in later problems as we have a few more things going on. But here, this U plus 2 is equal to 3. As the algebra would indicate, we want to get U by itself, which is simply subtracting 2 on both sides. And, well, we already got U by itself. Again, it may not make as much sense here. It'll make more sense in future problems. But upon getting the variable simplified, now we can, so if you do remember U substitution, this means that we can plug in what the U was representing. U was representing sine of x. So now we plug in sine of x for u. So instead of u is equal to 1, it's sine of x is equal to 1. And so from here, we're trying to solve, so that's the algebra. That's where the algebra comes into play, is getting the trigonometric function isolated by itself. So now that the algebra is done, now the trig kicks in. So how do we go from sine of x to just x? And so this is when we have to think about constructing the triangle and using triangulation. So what you would perhaps do, and don't write this next part down. So don't write the stuff in red that I'm writing. So you might look at this and think, okay, this is opposite over hypotenuse, which would be 1 over 1. And you would start to build the triangle. Well, one question is, where does the triangle go? And your thought process may be, okay, well, sine is positive in quadrants 1 and 2. So you would start to construct a triangle in quadrant 1 to get the reference angle and then figure out what quadrant 2 has to be. And so opposite is 1, hypotenuse is 1, and then you would end up getting 0. So all of this was an elongated way of saying that we have a quadrantal. So this triangle doesn't make any sense. So that's why I didn't want you to write that part down. You would go through all those motions and then realize we have a quadrantal. So everything in red, I'm going to go ahead and erase it. So triangulation doesn't work. This is a quadrantal, which means we need to generalize to those formulas. Sine of x, if you possibly recall, is y divided by r. And really, what we want to look at are the points on the axes 1, 0, 0, 1, negative 1, 0, 0, negative 1. Those ordered pairs, we need to look at these and figure out which pair or pairs give us 1 for sine. Remember, each one of these is an x and then a y, and then r is going to simply be found by, well, r in each one of these cases is 1. So there's only one of these that when we look at y divided by r, we will actually get 1. It's this one. So here y is 1, x is 0, and then r, which is well, it's not really the hypotenuse, but it is found by the Pythagorean theorem, which would also be 1. So really, it's this point right here, which means this angle is the value for x. That angle is 90 degrees. But we want to put that into radians. The reason why, it's implied by the specification of the domain. Over the interval 0 to 2 pi has an implication that we want to write this as its radian equivalent. So we have pi over 2 radians. So that is x here. Really what this should say is x is equal. So this is a little complex. It brings together a lot of things. So that would be our answer. Does anyone have any questions before we move on? If not, let's look at example 2. Tan to the third of x is equal to 3 tan of x. The first thing I'm going to do, well, we need to take care of the algebraic part first. The algebra, well, the goal is to get the trigonometric function by itself, but this is where the u substitution is going to be helpful. So the trig function here is tangent of x. So guess what the u is? It's tangent of x. This is merely a way to just simplify the problem. It's a lot easier to work with when you swap out the trig function for just some dummy variable. So here it would be u to the third is equal to 3 times u. So every place I saw tangent, I just swapped it out with a u. And now we want to get u by itself. The way we get u by itself, well, this is, of course, this is where the algebra comes into play. Pretend like this was some sort of polynomial from algebra. You would subtract both sides by 3u. So you can utilize the fact that both of these terms have a u in common. So you can factor out the common u. Oops, forgot a 3. And so remember from algebra, factoring is nice because each individual part now gets individually set equal to 0. And then from there, one of them is already solved for. The other one we need to work out a little bit further. So that'd be u squared is equal to 3, and ultimately u is equal to plus or minus the square root of 3. Because we take the square root of both sides to get u by itself. And whenever you apply square root, you have to implement plus or minus. So what did u represent this whole time? U was a placeholder for tangent of x. So now we have, this was the scratch word, so instead of u is equal to 0, now we have tan of x is equal to 0. Instead of u is equal to plus or minus the square root of 3, we now have tan of x is equal to plus or minus square root of 3. And now we have to solve each one of these individually. Now tangent of x is equal to 0. If you try to use triangulation to solve that, you would get that tangent of x, well, that's opposite over adjacent. But if you try to construct a triangle out of that, you get that the opposite segment length is 0. So this is a quadrental. This is a quadrental. You cannot use triangulation for tangent of x. So you have to remember that tangent of x, you need to remember that the formula when dealing with the quadrentals is y divided by x, or sine divided by cosine generalized. So when you think about the quadrentals, well, I drew this above, and I'll draw it here again. 1, 0, 0, 1, negative 1, 0, 0, negative 1. Now, all we need is y and x. Remember, it's x and y for each one of these. All we need is y divided by x to give us 0. And it looks like actually two of these give us that. Over here, y divided by x would be 0 divided by 1, and 0 divided by negative 1 as well. So for that first one alone, we actually get 2 answers. We get the angle that lies strictly on the x-axis, which is 0 radians. And then we get the angle that lies on the other side. It's 180 degrees, or pi radians. So that's the first part. Now we have to look at tangent of x is equal to plus or minus the square root of 3. Now it turns out this can be triangulated. It's opposite over adjacent with an understood 1. And so we ask ourselves, when we go to triangulate, what quadrant do we draw our angle in? Now the answer is, really we can draw the angle anywheres, because the plus or minus gives us the option. This is all quadrants. It's happening in all 4 quadrants. The plus, when is tangent positive? Tangent is positive in the first quadrant and the third quadrant. When is tangent negative? In the second quadrant and the fourth quadrant. And because we have plus or minus, we consider all 4 of the quadrants. But to figure them out really easily, we're going to triangulate in the first quadrant so we can figure out the reference angle. Once we figure out the reference angle, we can figure out the other ones really quickly. So opposite is square root of 3. Adjacent is 1. You might notice that this is a special triangle. Hypotenuse is going to be 2. Which this triangle tells you that what angle is across from the square root of 3? It's 60 degrees. So the reference angle is 60 degrees, and it's also our first answer. but we need it in radians. So this is the quadrant 1 answer. But we're going to have this equivalent answer in every other quadrant. So what's the answer in quadrant 2? Well, that's when we use the reference angle. 180 degrees minus 60 degrees. So 180 minus 60, that's 120. I'm just going to go ahead and convert that to radians. So it's 2 pi over 3 radians. And then the quadrant 3 answer. This is going to be 180 plus 60, because 60 is still the reference angle. That's 240. And the radian value is 4 pi over 3. And then finally, we need to figure out the one in quadrant 4. Which is 360 minus 60. So that's 300. This is 5 pi over 3, which is the quadrant 4 answer. So we actually get 6 answers. We get 6 answers from this. We get 0 and pi, pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Okay. Yes?
Is the 0 the answer for x? The 0 is from one of 2 answers that we got on the first one.
You're asking if 0 is...
Like 0 pi. Are there 2 separate answers or 2?
Yeah, that's 2 separate answers.
Yeah, I just checked.
Yeah, we get 6 answers in total. So there's a reason why we say these problems for last. This pretty much brings everything together. So example 3 might be a little bit easier. We want to solve cosine squared of x plus 2 cosine of x plus 1 is equal to 0. And same thing, we want to solve over the interval from 0 to 2 pi. And the first thing we're going to do is go ahead and apply the u substitution. I see a bunch of cosines, so I'm assuming that's going to be my u. And now every time I see cosine, I'm just going to replace it with a u. 2u plus 1 is equal to 0. So I applied the u substitution by just simply replacing every cosine with a u. And now it's a algebra problem. This is strictly an algebra problem. So this is something you would factor. So it seems like it's u plus 1 is equal to 0. And from here, factoring is nice because you set each part individually equal to 0. And you ultimately get that u is -1. So you factor the quadratic. Factoring means you set each part individually equal to 0. And then once we did that, we could solve for u. And since the parts were the same, we only have to do it once. So that was the algebra. Now we can plug in cosine of x for u. And now we can figure out how to get x by itself. So this is where the trig comes into play. And so here, when we try to figure out, all right, your thought process would be, all right, so this is adjacent over hypotenuse, and you would start to try and draw up the triangle. You would also try to think about where is cosine negative. Cosine is negative in the second quadrant and the third quadrant. There's a reason why this is in red, by the way, so you might not want to write this down. So you would think about what quadrant this is in. Cosine is negative in the second and third quadrant. So I would draw a triangle in the second quadrant. And so you would put a -1 down here and a 1 up here, and then you would end up getting a 0. So what you will end up coming across is that you would get a quadrantal, which means triangulation will not work here. That means none of this will be any helpful. And we must rely on the idea of quadrantals. So by looking at quadrantals, when we go and construct the graph, it's going to be a very familiar graph. One comma 0, 0 comma 1, -1 comma 0, 0 comma -1. And the formula, the quadrantal formula for cosine is x divided by r. Or really, in essence, r is always just 1. Every time we look at these, in the quadrantal case, r is always 1. So we need to figure out, since all of these are xy pairs, which one or ones contribute to -1 for x. And that's this one, which is 180 degrees. Or rather, pi radians. So we only get one answer here. Does anyone have any questions before we move on? If not, move on to example 4. So it says find all solutions. We're just going to find the solutions from 0 to 2 pi again, which means we're going to be working out the problems the same way. There's something a little bit more technical about this wording. So yeah, we're just going to reduce it down. So we have another problem. It's sine squared of x minus sine of x is equal to 0. And the first thing we're going to do is convert this into an algebra problem by applying a u substitution. I see sine, I replace sine. And every place I see a sine, I'm going to put u's. Now, from here, hopefully it's clear that the algebraic situation would imply that we factor out a common u. Both of these terms have a u in common. So then u times u minus 1 is equal to 0 after we factor out the common u. And we can set both of these individually equal to 0. So u is equal to 0, u minus 1 is equal to 0. One of them is solved. The other one, we need to take it one step further. And so from here, that's the algebra side of things. Now we're going to replace the u's with the trig function. So sine of x is equal to 0 for the first one, and sine of x is equal to 1 for the second one. And we're going to solve both of these individually. Now, in both situations, you're going to realize that we're dealing with quadrantals. You try and work out the triangle, you're going to see that triangulation does not work. So these are both going to be quadrantals. So these are both quadrantals. So I'm going to only draw one quadrantal graph. And this might look very familiar yet again. 1, 0, 0, 1, negative 1, 0, 0, negative 1. And sine is y divided by r. But for every quadrantal problem, r is always 1. So really, this is just y in both cases. So for the quadrantals, we're trying to figure out which angle measurements give us a y value of either 0 or 1. So the one that gives us a y value of 0 is these two, because they both have a y value of 0. Both of these are 0 and pi. So what about the ones that give us a y value of 1? Well, that's this top one. So that's pi over 2. So we get 3 answers here. Does anyone have any questions? We have one more. So this one might look a little bit interesting because we really have 2 trig functions occurring here. So in this situation, it's not completely evident what our u substitution would be. Because, well, there's 2 different trig functions here. There's cosine and there's sine. So really for this to work, we need we either need all cosines or all sines. Now the way we can do that, in fact, there's a few ways we could do that, but there's those Pythagorean identities. The Pythagorean identities, so we cannot use u substitution because there's a cosine and a sine. However, we know that, well, actually, there's a few different ways we can express this. One of the ways we can is that cosine squared is 1 minus sine squared of theta. That's one of the Pythagorean identities, which means I'm going to take this cosine on the far left and replace it with 1 minus sine squared of theta. And then the right-hand side stays the same. And so now we have all sines. So u is equal to sine of theta. Now we can proceed. 1 minus u squared is equal to u squared plus 1. I think I missed something here. Cosine squared is equal to sine squared plus 1. Cosine is 1 minus sine squared. I don't feel like it's supposed to come out like this. One second. Okay, so this is what I'm supposed to get. Cosine squared. Minus sine squared. That's so weird. Okay, well, we do it the way I know it works. Interesting. I don't think there would be much of a difference. I guess we'll apply the Pythagorean identity here. It's so strange. That shouldn't make any difference. One minus cosine squared of theta plus 1 cosine squared of theta is now 2 minus cosine squared of theta. And we can apply the u substitution. U squared is equal to 2 minus u squared. 2u squared is equal to 2, and u squared is equal to 1. Oh, I see what I did wrong now. Never mind. It did work. I'm just overthinking it. So we changed everything to cosines, and from here we apply the substitution, and the algebra allows us to ultimately solve for u. And then the last step, we apply the square root, but the square root of 1 is just 1. So instead of u is equal to plus or minus 1, we now have cosine theta is equal to plus or minus 1. So this means, since we have a plus or minus, well, if you go to triangulate, you're going to figure out that this does not work. It does not give you a triangle that you can use. So you get a quadrantal. A fairly prevalent theme throughout these problems. So cosine is x divided by r, but as I mentioned, r is always just 1 in all of our cases. So really it's just x. So we look at our quadrantal graph yet again. On 0, 0, 1, negative 1, 0, 0, negative 1. And we look for all the values of x such that we get plus either positive 1 or negative 1 for x. So positive 1 here, negative 1 here, and that's it. So those two correspond to 0 degrees and 180 degrees, which we leave the answer as this because the domain is formatted in degrees. So we leave the answer in degrees. Does anyone have any questions about this? All right, so I suppose with the remainder of time, should I go over some of the homework problems, or should we just call it a day? You think you can figure them out on your own, we can get out 30 minutes early. If you don't think you could finish them on your own, it might be good to utilize this class time because I'm going to make this homework due Thursday. This homework is going to be due Thursday, which is 2 days from today. No, no one's saying anything, so I'll just do it myself.